software with our music. For instance, the most very known tool, MIDI toolbox, which has an inspiration to my study, contains many applications based on the 12-tone equal temperament, 12-tet system, and none of which are directly applicable to our music, Turkish music. For example, this graph, the pitch class distribution statistical and graphics tool, PC disk, cannot be used in the Turkish Compmusic, which provides both orally and visually very valuable outputs, but we cannot use. Why? There are two main reasons. We have more than 12 tone in there, and the concept of the pitch class does not match, does not apply, and therefore reduction of all tones to an there may lead to erroneous results. A similar situation exists for the interval distribution statistics and graphics tool, IV dist. While all intervals in the 12-tet system are integer multiples of a half tone, the intervals in our music cannot be quantified and plotted with these two. So we have decided to do such a research. Some feature of our symbolic database. The database converted from the MUS2 Alpha, the pre-released version of MUS2, the first developed notation and plate-based program in Turkey. This format has a number of distinct advantages. One is the values separated by a comma delimited file, CSV file. They are also being transformed into Access database to allow for the advantages of the structured query language, SQL. We talked about database deeply yesterday, so I read this sham into the presentation. The MUS2 Alpha database structure relations are like this. In the center there is pieces, words, and there are some key areas. For example, makam, for example, form, usul. There are many problems. For example, how can Kürdili Icazkar write? How should we write Kürdili Icazkar, etc. So we solve this problem putting a key and writing makam's name in a different area. Yes, we can back to this point. Here is an example of Turkish music. Especially, I want to say some things about notation. The MUS2 Alpha uses notation based on 53 tone equal temperament, 53-tet system. This allows storage in a format compatible both with the official RLSG Ultimate system and with that employed in the folk music. Because, for example, look at this sign. This is not usually used in classical Turkish music scores, especially that two sign, but it is using in Turkish folk music. So using the 53 head system, we combine all of them. We can approach the 53 head system as superset of their combinations. And there are some ornamentation symbols. We'll back this point. Now there's a summary about statistic. Total scores, there are 15,100 scores in the database, and more than 100,000 notes were used there. Classical works are 1,200, etc. Look at this 3 point especially. There are 150 distinct makams in our database. Top 3 of them, Hijaz with 94 pieces, Uşak 74 pieces, etc. There are a number of 95 usus in the database. 230 are Sofyan, in Sofyan, Aksa, Gürcüler, you can see. And forms, there are 32 different forms. Şarkı, 530, Türkü, Seyir, etc. And 400 works are instrumental, the others all vocal. There are only 40 religious works in the database. The pre-release version of the Musiki format aims to accommodate sheet music publishing as well as internationally accurate playback. For this reason, it also includes many nuance, navigation, and ornamentation symbols. This original format, not suitable for work that will be done in Compmusic. The entire piece has been generated in a linear fashion similar to the MIDI files. On the other hand, the use of dynamics and ornamentation symbols in Turkish classical and folk music is very rare. Especially dynamic marks are almost non-existent. Ornamentations usually consist of grace notes and sometimes tremolos. Nearly all other symbols in the Musiki Alpha database were added by us. For these reasons, we have chosen to devise a new format and convert from the existing database. The important processes during this conversion are repeats were copied all the appropriate locations. For example, in a score with peşre form, the teslim section was copied to 4 different locations. Second of them, grace notes were represented as regular notes, but the rhythmic value of each grace note was subtracted from the leading or following note based on the note's rhythmic value. And all the ornamentation codes were added manually were reduced, replaced by normal notes. The new note was made similar to the MIDI 2-watt note matrix format. Beat and second information for starting and duration. And the others are some meanings. The start or onset and duration fields have two different forms because it may be possible to change the tempo in a piece. The middle channel field is, as you know, there are 16 possible values, and this parameter, pitch or no parameter, is middle no number. As we can see, this one is 69. And velocity takes a value between 0 and 127 and denotes the volume of the sound. As you can see, there are in beats or in seconds 0.9 values here, because if there is a staccato or legato sign, we can adjust them with these parameters. The same TR format for the same score is now I am going to show it, but first of all we do a computation. A4 69, there's no difference, but B4 there are 9 commas between these two notes, so 1200 divided 53 equals 204 cents or 2.04 cents. So we write its value as 71 or 0.04, and similar computation can be done, and we can compute this value. When we are writing in the database, we multiply the values by 100. Look at and let's look at the SymTR format. These names are generally in Turkish. And nota or note pitch field contains the note name, octave, and flat sharp values in commas. For example, these are have commas, but this one C or E, fourth octave, and flat 1 comma. This field, as we see, is in cent, not no middle number. And there's another field here, pi bölü payda. It can be translated in English. Numerator divide denominator. In fact, it means one fourth, all of them, as you can see the score. Duration is in milliseconds. This field is similar to middle to last note matrix. Let's read it from here. It defines whether the note is to be played as legato, normal, or staccato. The value is a percentage. So 100 means full legato. So the note will be played for its entire duration. 50 means the note will be played for half of its length as staccato. The default value is 95. Rests are also represented by this field, fields value. And velocity on, velocity of fields, these are syllables. In fact, if we have these values, we cannot need node names because they can be computed from, if this is known, also this is known, but it is easy to follow the score if we put the format in it. Our objectives, some objective of our research is melodic investigation, melodic contour processing, melodic segmentation, melodic similarity measurement, melodic complexity computation, melodic expectation determination. Among the practical application of these studies are, for example, melodic contour, searching a musical motif or pattern in various databases, melodic similarity, copyright, melodic complexity, popularity or longevity of musical words, melodic expectancy, composition. Another example, makam identification, through comparison by correlating analysis or the correlation analysis of the histograms or work with the unknown makam with the no duration histograms of database from 40 makams. Similar second method, similar to method 1, but employing the interval histograms, and third algorithm. Example, this is a şarkı in uşak makam, kimseler gelmez, composer is Şevki Bey. The red bars on the left signify the percent share of each note with respect to number of times each note is sounded, and the blue bars display the percentage in terms of note durations. For example, yes, this, look at this page. This is Dugas page. This is sounded approximately 40% of the total playing time, whereas this note constitutes only 8% of the total note count. And interval histogram for the same word, the left side with minus sign are belonging to decreasing intervals. Look at this, for example, higher one, according to figure, about 28 intervals are decreasing, major second minus 9 comma, and for example this one 7% are increasing small half tone or comma or papilla in traditional name. And these are the pitch and interval histograms of Uşak makam for 74 cases in the database. As is known, the program compares the histograms, especially pitch histograms, and find the makam. And this study is practically used identification of the makams of the words in the Turkish folk music repertoire, because there aren't makam information on the folk music repertoire. correcting the erratic makam classification in the classical Turkish music repertoire, and constituting a makam tree employing the song method. What is the
organizing?
Yes.
Maps.
Yes, if we have some more time, I want to show some examples by running the program every time.
We forgot to mention that this is just a start. We made recently, very recently. So what we did with the audio, we should have it in 1 month or so. See what happens in symbolic data. So it was that kind of work. It's not the main direction we will follow. The main direction will be more melody progression analysis.
There are, in fact, there are 2,500 pieces in the database, but because of the copyright, we include only 100 and 500 of them. The original format was here. For example, this is a şarkı, yegah makam, yegah makam, benim gözüm nuru. The note information is like this. As you can see, notes names are written, and 108, 104 for note durations, not note values. These codes are for repetitions. For example, these are some repeat symbols, etc. But it is more suitable to use a linear form, so we convert them in our format. Look at this. Too many examples are here. Some of them are in vocal or some of instrumental. Now, first computation are here. Look at this same song is now a different format. Sang, millisecond, etc. We can play them. We can plot the pitch histogram. This is in yegah makam, and this is the internal histogram. And there are pre-computed histograms for all makams. For example, ARP makam. Pitch histogram is like this. Interval histogram is like this. There are 42 pieces in this makam. And there are 40 of them. Yes. Now,
Yes, you did a test of recognizing makams with matching instruments.
Yes.
It was much more successful than the audio test, of course.
Let's start.
Just talk about the relevance of the histogram.
The histograms are all included in the same software. So you generate the histograms from the.
Yeah, this is the software you wrote.
It's all everything inside.
Yes, but not in the encyclopedia.
Oh, okay.
This is a separate.
This is a separate.
Yes, he wanted to work.
This is just for research purposes. So this.
Yes, especially.
Okay, so you just developed it for testing.
For example, let's look at this song. We know, in fact, it's makam, but want to control, to check it. It uses two methods, one for red bars, one for blue bars. Both of them gives the best result. We can read this information as 82 or 80%. This word is in Islam makam. But sometimes there are confusions. For example, some songs, some pieces may be classified in different makams. One of them is this. We have classified it in Ajam Kurdi makam, but there are some sources which classify this in Muayyer Kurdi makam. So let's find its makam. Yes. In fact, Muayyer Kurdi is more suitable. Its structure, Ajam Kurdi is the second, but it is known generally in Ajam Kurdi makam. And there are about 25,000 notes in Turkish folk music repertoire in Turkish Broadcasting Corporation, which aren't classified as makams, so we can use these tools to do that task.
You mean the radio television's database?
Yes, yes. As you know, they are classified as regions.
Yeah.
But
They have
all makam structure, makam. So we can do this. Yes.
If I could add one comment on this, well, the similarity of makams, for example, is an important information, can be an important information in education or also in understanding music. This is not available through literature. And this kind of tools would help us to understand at least one makam being close to another. And maybe if there is an intelligent way to put them on a map, this could also help. I mean, well, in literature you wouldn't find anything that talks about closeness of makams or so. Only when they teach, sometimes a certain makam is explained through another makam. That's the only information we have. It says it's like this one, but it has more assembly character. This is the only information we have. But once we have all these histograms, temporal matches, and everything, we will have the tools to show us more information than the literature has, I think, on makams, being able to compare them. For example, these melodic progression features, I have shown to some masters. Well, I have shown that overall progression, and asked them, okay, if you would have a tool to see those, would that help the student to learn about it? They said absolutely. So